All right, so any questions on Chapter 2, the reading? Before I talk about it in more detail.
The same as the classes?
Yep, pretty much the same. All right, so in that case, I'll just start at the beginning. So Java is a very object-oriented language, and by that we mean that everything we see in the world is represented as a thing. A computer is a computer, it's a thing. It has USB ports, it has what do it have? Optical drives of some sort. It has speakers. You can turn it on, you can turn it off, you can kick it if you want to, though it doesn't really help. And in Java, objects are exactly the same sort of concept. In object-oriented programming languages, objects have properties and operations, attributes and operations. In Java, these are usually termed properties and methods. Properties are not something in Java that's directly implemented. Properties are a combination of two other constructs. One is variables and one is methods. So using variables and methods together in a very specific way allows us to treat an attribute of this object as a property. But attributes and operations are still very much programming language ideas. Variables representing the attributes and methods representing the operations. That can be either done on an object or done to an object. And that's where the book starts off its discussion. The book uses an example of a throttle, much like you would find in an airplane, not so much like you would find in a car. And the basic structure of this throttle class, which represents the idea of what a throttle is, not a very specific throttle, that would be an object, but an idea of what a throttle is. Much the way when we talk about a chair, we're talking about a concept, and when I point to that chair and say, I'm talking about that chair, I'm talking about an instance of a chair. So in that case, chair would be the class, and that chair would be the object. So to create this new class, we say public class, and in this case it's throttle. And this shouldn't be totally foreign to you. You've seen this before, even just writing simple programs, even programs that just have a main method, and including programs that have a main method and some other methods as well. That's because in Java, everything has to be inside a class. You don't get a choice in that decision. In Java, everything needs to be in a class because Java is very object-oriented, and the philosophy in Java is that it doesn't make sense to have something that's not associated with an object. You can't have nothing doing something. That just doesn't make sense. So even if you have a main method, it needs to have some class that it's associated with. In the programming assignments, I give that an arbitrary name. I call it main. That seems to be a pretty popular convention in a lot of object-oriented languages. When it doesn't make sense for the entry point to have a meaningful class name, we just create a class called main and say this is where the program starts. C# uses program as the name of the class, does exactly the same thing. We just pick a name. But for classes that actually represent real-world objects, we can use the real-world object name. So this class represents a throttle. We'll call it throttle. the first thing we have, where did my cursor go? The first thing we have in a class is instance variables, and these represent the attributes of the class. We're going to give them a keyword private for now, and I'll explain why that is when we talk about a very special type of methods that complete the propertyhood of these attributes. But for now, the keyword private means that anything outside of this class cannot see this particular variable. So we create two variables, one that represents the top of the throttle, the highest value it can have. The assumption is that this throttle goes from 0 to some number, 0 to 60 for instance. And then the position represents its current value, how far along that range the throttle is positioned. And as I said, they have the private keyword. The class itself has the public keyword, which means that anything and everything in the world, well, in Java land, can see this class. There are also two other keywords like this that are called visibility modifiers. One is package, and one is protected. Protected, we'll talk about. Oddly, this book has inheritance and abstract classes toward the end of the book. That's when we'll talk about protected. Package, we'll talk about toward the end of this class. It's later on in the chapter. If you don't specify a visibility modifier, the visibility is equivalent to package. So, in general, always, it's good practice, always, to specify either public or private. When we learn what protected means, there are also very important cases when protected is useful. So at that point, it'll be necessary to declare everything with public, private, or protected visibility. And these are both instance variables. We haven't talked about class variables or class methods. We'll talk about them toward the end of the chapter. So in order to access any of this, I would need to create an instance of this class, which we'll get to later on. So if we need an instance of this class in order to get to any of these variables, what process needs to take place in order to do that? We have to define, well, it turns out we don't really have to define how that happens, but it's useful to. And that's called a constructor. And this looks like any other method declaration, except that you don't have a return type. So it's just public and then the name of the class. That name, you can't change that name. You can't call it create new throttle. That doesn't make it a constructor. The name of the method has to be exactly the same as the name of the class. And in fact, if you named it something else and didn't have a return type, the compilation would fail. The only way to have the compilation not fail when you don't specify a return type is to have the method name be exactly the same as the class and have it be a constructor.
And even though the constructor does not have a return type, you still cannot do even a void, because that would make it a method, not a constructor.
Correct. In fact, I think Java will say you're probably doing something stupid here. You can't do that.
Right.
It probably won't let you create a method with the same name as the class. So in this case, we're going to let it take an argument. An integer called size. And the constructor should do some initialization. We'll set top equal to size and position equal to 0. And to make it look exactly like what's in the book, or almost exactly like what's in the book, we'll do some error checking. Size is less than or equal to 0. No new illegal argument exception. Size less than or equal to 0. Size. That checks to make sure that size is something that actually makes sense, and if it doesn't make sense, it throws an exception, basically telling Java that this is wrong, blow up now. Not so good if this throttle is in an airplane. Now, if I didn't provide this constructor, Java would automatically provide what's called a no arguments constructor for me. That means, very simply, it doesn't take any arguments. Basically, public throttle, open parentheses, close parentheses, open curly braces, close curly braces. That's what it provides for me. It just provides a default way to create objects of this class. As soon as I define any constructor with any number of arguments of any type, it automatically does not provide the default no-args constructor. So if I wanted to be able to create a throttle and not specify an initial size, which, judging by what I'm doing with the size, I probably don't want to do that, Java will not provide. If I want a no-args constructor, I need to define it myself. So by not defining a no-args constructor, I am saying you have to specify a size in order to use this throttle. And there's a reason for implementing the methods that we're implementing in this order. This order is a convention. Constructors come first. The next type of methods that we'll implement come next. More general methods that aren't that type come after that. And that's something called helper methods, which are private, not accessible to the outside world, that are called by the public methods, go last. So I can put some comments in here. Constructors come first. So this special type of method is called accessor and mutator. Basically a fancy word for getter and setter. The reason they're usually called getter and setter is because they have get and set in the name. And these methods very simply get and set the values of my private instance variables. And they also have a naming convention. And that convention is get and the name of the instance variable, the whole thing properly camel cased, and set and the name of the variable, the whole thing properly camel cased. So here we would want a method like that.
a method like that, and a similar thing for the other methods. Now these are what are called method stubs.
They don't do anything. They're just the shell. And in fact, like this, it won't compile.
Because this is declared as returning an int and doesn't return an int. And this method is declared as returning an int and also does not return an int. So we can fix that pretty easily. And in fact, the easy way and the right way are equally easy. So we might as well just do the right way. Return top. Now for set top,
We want to take the argument called top and set the instance variable, also called top, to that value.
yes.
What I have written on line 19 will not work because top is local to the method. There's only one top that the method sees.
However, that doesn't prevent the class level top from existing. And there's a special keyword called this that refers to the current instance of the class.
So set top being an instance method is called on an instance of the throttle class, therefore it knows about its own instance. And that's represented by the this keyword. So this dot top is the class level variable. Top by itself is the local method variable.
We can do something similar for get position and set position.
So there are some very good reasons why you shouldn't make instance variables public and should instead make them private and have public accessors and mutators. Does anyone want to make a guess as to any or all of them, or remember any of them from last semester?
Well, it prevents the user from tampering with the method itself, and they can change the position or the size, and it will be, if it was public, it will be changed for good. But since it's private, you can't do it.
So, yes, right direction, yeah.
Another thing in my last class last semester, they said that say you had something like social security numbers and you don't want somebody to see what the social security number is, but you still need to be able to access it from the main program. They can access it through a getter, but they can just never see it. So they're not actually viewing the information, but still being accessed.
Another good example. The two main issues that I come across are when you want to be able to set something but not get something, or more frequently, get something but not be able to set something, and if you want to do some error checking. There are certain things that setting and not being able to get that doesn't really make sense. Being able to get something and not set it does make sense. For instance, if you're dealing with something that you get from somewhere else, it has a unique ID associated with it. You might want to get that instance variable, that value, that unique ID, so that you can use it somewhere else in your program. But you don't want to change that on your object because that would just be all kinds of wrong. the data in that object would no longer, it would not be associated with whatever ID you set it to. Basically, making things read only. Your computer seems to be having issues there. And the other one is error handling, and we'll actually use that here. I'm actually going to pull this bit of code from the constructor and paste it in there. So if I try to set the size of the throttle to smaller than 0 or smaller, it should still blow up, whether I set that in the constructor or set that using the mutator. If the variable were public, I would have no control over that. Anyone using an instance of this throttle class could change it to whatever value they wanted.
They could change it to -327 just because they felt like it. And similarly, though this isn't really error checking,
We should probably make sure that the position of the throttle is not higher than the maximum value of the throttle.
so if the current position, that's not where I want to do it. Still want to do it in set top. If the size is greater than, no. What's the logic I want here? If size is less than, we can have a position equal to the size, the top value. So if size is less than position, let's set position equal to top. And that's going to have to be top in both places because we're not intro to Java, we're data structures. Okay. So now we can move on to public methods.
There's also a convention in Java that any method that returns a Boolean should probably start with the word is. That way, when you're reading code that uses those methods, it reads kind of like an English sentence. In this example, the author uses the isOn method. So, is the throttle on?
So it's a Boolean method. And oops, there we go, breaking convention again. If position is greater than 0, return true. And if we don't return true there, return false. Yes, you could put an else at the beginning of that line,
But it's really not necessary. If the if part doesn't execute, then it's the only way it's going to drop down to the line after the if part is if it doesn't return, which means the if part didn't execute, which means it's the else case anyway.
and close that method. And we also have some methods for doing stuff. So this is a method called shut off. And all that does is set position equal to 0.
So that isOn no longer returns true.
I should note that the author actually simplifies these 3 lines into 1 line.
Because what we're doing is saying, if Boolean expression, then return true. If this Boolean expression is, if we're returning true, this Boolean expression is true. So we might as well just return the sense of that Boolean expression. So
the author shortens it to that. And now I'm convinced that he's a C programmer because most Java programmers would write it the other way.
this is far more elegant and far more descriptive. Far less verbose. You're shaving a few bytes off your Java source files. Does everyone follow that? That's one of those subtle things that kind of can trip people up. But if you're reading code from someone who's been programming for a very long time, they'll probably do things like this. And this class is so simple that it doesn't actually have any helper methods. Though I suppose it would help. This throttle really can't do much. I might want to have some way of increasing its onness. So we have a method called shift. And let's do that. Can anybody tell me what some problems with my implementation of shift might be? So what happens if I have a throttle that can go up to 4 and it's at position 2 and I give it an amount of 30? I'm clearly firing the afterburners. No, the correct answer is that doesn't make any sense. So we should make sure, just like we did everywhere else, that our new position is not greater than top. And position is also not less than 0. And in case they put a negative number, make it, try to, I don't know, they're trying to go in reverse or something.
Why do you put it on the same line? Is there a convention or you can do it either way?
Can do it either way. I was going to blame it on the author, but the author doesn't do that.
When I start seeing C conventions, I start going back to all my C conventions. It's
really doesn't make all that much of a difference. When it's one short line that's being executed in the if condition, I usually put it on the same line, just because it reads like a sentence that way, and it's only one line. I think the code looks more poetic that way. If I did that, that would be bad because I'm not following any convention.
if I do that, it feels kind of jagged to me. Either is equally acceptable. I certainly won't take off points if you follow one convention over the other. The most important thing I can say about conventions is that you pick one and stay with it. Certainly within the same class file, hopefully within the same project, it's okay if your conventions evolve over time. I know my conventions have. I know I've broken conventions within the same project because I write the first version when my conventions are one thing. My conventions evolve, I go back and modify that project, and everything I modify follows the new convention.
We'll just walk out with an iPad, John.
Okay. Right. So that is the throttle class. Apparently, the author implements a method called getFlow, which returns position divided by top, both converted to doubles so that you get a fractional, basically a percentage, how much of the flow is occurring. And at that point, getFlow is both it's technically not an accessor because it's not tied to an instance variable. So it's technically one of these public methods. But it is also a helper method because they use it in the isOn. So, I guess we might as well implement that to be complete. So that's essentially the full implementation that's in the book. Questions so far? So we've created the description of what an object is. No. Where am I today? We've created the description of what a throttle is. We've created a way to interact with a throttle. We've created a way to... We've defined what should happen when we create a throttle. So let's go ahead and actually create a throttle. Let's call this class main. Let's create a method called public static void main. String args. Just to make sure everybody's on the same page, is anyone not familiar with the significance of the string args? Sweet. let's create a new throttle.
Okay, that will poll now. This will succeed. The compilation will succeed or fail. Those in favor of succeed. Those in favor of fail. Those in favor of I'm not quite sure yet, so I don't want to raise my hand. Okay.
Let's find out.
So the fails have it. Who knows why?
That's a no-arch constructor, so you don't have an no-arch constructor in the definition of the class. So that's why I put.
Correct. So how do I fix the error?
You can either do a no-arch constructor in the class, or you can specify what it is.
So let's assume that I have implemented the entire interface of throttle, and I shouldn't have anything in addition to that. So we'll go with the second approach and specify a size. And now at this point, this will, yeah. And run it, and it runs fine. So at this point,
We could try printing stuff out.
no, let's do that. Let's try printing stuff out. So at this point, I have a new throttle. Let's print out control.
Before I run it, who wants to tell me what's going to happen? Depending on how you define error, that could be an accurate explanation. Other acceptable responses could be along the lines of the behavior is undefined.
But what actually happens is that
It prints out something that doesn't really make sense. It's the name of the class, an @ sign, and it's actually a hexadecimal number, and that's the reference to the class.
Because you're not storing control in any
Because so I'll get to the reason why it's printing that out in a couple minutes. But this allows me to talk about, these are called reference types. The book makes a distinction between primitive types and reference types. Sometimes people will call them primitive types and class types. The difference is that primitive types are a single value, a single piece of data, and there are 8 of them, I think, 8 or 9. There are 4 integer types, byte, short, int, and long. There are 2 floating point types, double and float. Then there's Boolean and char. Some people pronounce it char. As far as I'm concerned, char is a fish, and the shortening of character is char. So 8 primitive data types, all store a single value. Anything that's a class, an instance of the class, is a class type. It does not store a single value. Instead, what is stored in the actual variable is a reference to some piece of memory somewhere that in Java you can't actually get to, that actually has all the information about that instance of the class. So since classes have an arbitrary size, they're just pointed to by this reference. And that's what that number represents. You could think of it as the address in memory where this throttle class is actually stored. That's not really how it works. It's just a key that it uses to look up where it should look for the throttle.
The important point is that that's nothing helpful to print out when we do system.out.println and then a throttle object. We can fix that, however, by implementing a method called toString. And it returns a string. And the method signature must be exactly like that.
The reason it must be exactly like that is a topic that comes up when we talk about inheritance. But for now, use that method signature.
And everything will work fine. So let's remember, it returns a string. So let's return empty string to make it a string so we can concatenate.
We can start this off with
a number. I take that back. Let's start it off with a string. Throttle. Position. Position. And top of top. And now when we print this out, now when we run this program,
we get throttle at position 0 and top of 100. Even if it really doesn't make sense that you will ever be printing out a particular object, implementing a toString is very beneficial for debugging. Because you can always system.out.println that object and get something sensible that you can look at and say, wait a minute, this object doesn't have the values for its attributes that I think it should at this point.
and as we
In this class, we're building upon previous pieces of the assignment. As things get more complicated, toString becomes more and more indispensable.
I have a question.
Yes.
How does toString get implemented in main? I've not seen it. So I see you have a system that I've got print line control, but where does the method toString get implemented?
in throttle. So what happens here is basically system.out.println is expecting a string as its argument. Control is something that is not a string.
So it asks the control object if it has a toString method. If it has a toString method, then it calls the toString method, and that's what it uses to convert the object into a string.
Okay.
Let's do something different. Control 2 equals new throttle.
What will that print out? I'm sorry? Correct. What will that print out, true or false? Okay, so we have people on opposite sides of the fence. Who said it would print out true? Would you like to explain your reasoning?
Other than the fact that we're creating the same instance and we're not modifying that instance. They're creating an instance that, so let's say the instances are literally the same.
Okay.
We're not changing something that we assume.
Okay. And someone over here said it was false.
I said it's false, but it's checking they're the same object. They're not the same object. They've got the same value, they have the same value. But they're not the same
Okay. I already did that, right? It prints out false.
And the reasoning you gave is correct. It does create throttle objects with the same constructor parameters, but because it actually calls the constructor twice, it creates two different objects which are in two different memory locations. Control points to one and control 2 points to the other one.
And if we I wish I could do that. Wish there were a key combination to automatically comment those things out. Please tell me there is. So if I do that and compile, and then run,
Now it's obvious that it's two different throttle objects with two different reference pointers.
That's definitely something to watch out for. It's very tempting.
I've done it before. It's extremely tempting to say, oh, these two objects have exactly the same members. Let me use the equals operator, the equality operator, to see if they're equal. That doesn't work.
There's actually a method that you can
Implement called equals, and then you can call that method called equals, and inside that method you define how you're testing equality. So if the only thing you want to use to determine equality between throttles is that their top position is the same, you can do that in the equals method that you define. If you want them to be equivalent on both top and position, then
you can implement that in your equals method. Now let's do something really cool. Did I spell that right? I did. Any guesses as to what will happen? It didn't do what I wanted it to do. Java is a little bit smarter than apparently I am. If you pass a null to system.out.println, it says, this is a null. I'm going to print null. However, if you call a method on something that is null, it all kinds of explodes.
And if you look at the top of that output,
It shows a no pointer exception. That basically means
okay, so Java doesn't have pointers. And lots of people say that. In reality, it has references which behave kind of like pointers, and that's why there's a null pointer exception. Null pointer exception means that there was something that was null, and you tried to do something with null that you can't do with null. For instance, call a method on it. You can't do that. Even though the null is stored in a variable of type throttle, which does have a toString method, an instance that is null does not have any methods. So, with that in mind, what happened to the thing that control2 was pointing to when I set it to null?
So, I'm going to see if I can draw a diagram in comments that will help explain this. So, we have control, and it is pointing to with throttle might as well just use that. And control2 is pointing to this. And that's, so when we print out control, this is what our state is. When we print out control2, this is what our state is. That doesn't change anything. When we set control2 to null, basically what we're doing is that. So now we have control pointing to an instance of throttle. We have control2 pointing nowhere. And we have an instance of throttle that was being pointed to and is no longer being pointed to. So what happens to it? It gets deleted. Those of you familiar with C, if you did that, it would just stay around. It would be leaked memory. Java doesn't do that. It has something called garbage collection, which means if a piece of memory, if an object in memory is not being pointed to, is not being referenced by any variable, the garbage collector comes along and says, this is not being used, and it eats it, kind of like Cookie Monster eating tires, for some reason. I have that image. So it's just the bits and pieces that aren't being used anymore, aren't being pointed to by anything, just get reclaimed, and that's available memory. This doesn't happen immediately. Garbage collection happens when Java feels like making it happen, which is why it's very easy to eat up all the memory in your system very quickly. One way to do that is to retain references to everything, which is bad in its own way. And the other way to do it is to create new objects and assign them to a variable and have a lot of objects lined up that are waiting for garbage collection and not giving the garbage collection process any time to run. So Java is formulated so that you don't have to think about managing your own memory, but when you start using lots and lots of memory, it becomes useful to at least be mindful of it. And data structures, some of the more complicated ones, because you're assigning classes to pointers, classes to variables, instances of classes to variables, creating new instances of classes, creating other new instances of classes, replacing instances of classes with other instances of classes. Eventually, it can get kind of unwieldy and eat up a significant amount of memory. The examples that we're using, we probably won't get anywhere near the memory capacities on these machines. They're like 4 gigs or something like that. So we should be okay. But keep that in mind, especially if you start doing your own projects. Don't do computer vision in Java. You eat up lots of memory, and you kill machines with upwards of 16 gigabytes of memory. It's not good. So we saw the equality issue. Let's now, instead of assigning control 2 to null, let's assign control 2 to or the other way around.
Let's have this statement, line 8.
Using this diagram here, so this is still accurate to some degree. Control 2 no longer points to this instance. But after line 8, what will control 2 point to? Correct. So this goes away. So now we have two variables
pointing to the same instance. The book makes this very clear and says this does not perform a clone. You don't make a copy of control and put it in control 2. The only thing that gets copied from control to control 2 is the reference. So you can think of control and control 2 actually storing a number, that number being 29CD2795. And both of them store that same number. So they're both referring to the same instance.
So
If you repeat line 7, it's going to be true.
repeat lines. Yes. So that is byproduct number 1. And if I do that and then print out control 2, it will say that that one also has been shifted 40. Once I get this guy back.
Any questions?
Control dot shift 40, that changes basically the size.
That shifts position forward 40, so I want to go faster.
Oh, right.
But if you do control dot shift minus 40, it's still going to be flat at position 0. Not that one.
Yes.
All right. So I mentioned that package was a visibility modifier before. Package is only really a visibility modifier when you have multiple packages. Packages are basically groups of classes. The book uses
The term Java class libraries.
to refer to the Java framework. I usually call it the Java framework. The Java framework is organized into a series of packages, which are hierarchically organized collections of classes.
So when we use keyboard input, we do something like import java.util.scanner. Scanner is a class.
It exists inside the java.util package, which means that it exists inside the util package, which exists inside the Java package.
You can create your own packages if you don't specify that your class is in a package. It's in something called the default package.
Basically, the highest level package you can have.
Let's do something like this. What happened there? There we go.
This is a simple statement that says this class is in the edu.uccs.cs1450.airplane package. In reality, these package names are supposed to reflect the directory hierarchy you use to get to that class. So this should be inside a folder called edu. No, this should be inside a folder called airplane, which is inside a folder called CS1450. That's inside a folder called UCCS. That's inside a folder called edu. That's a lot of overhead for the programs that we're writing. So completely ignore saying that your classes are inside packages, worrying about the directory structures. More advanced IDEs that manage the location of your classes for you use packages, and that's a good thing. For our programs, use the default package, don't use any directories, don't put line 3 or anything that looks like it in your program.
The last note on packages is that they follow reverse domain name syntax, which means if I'm working for a company that's whose website is at synapsesoftware.com, I should write my packages using inside com.synapsesoftware.something else. If I'm writing code for this class, I kind of made up the domain name. There's no airplane.cs1450.uccs.edu. But the idea is the same. uccs.edu is the domain. Flip that around and then start adding hierarchically smaller pieces to the end. In general, it's domain name, or reverse version of domain name dot department or division of company or whatever dot project name, and then beyond that you can have certain packages to group together certain large chunks of the project. And that's really up to convention. There's nothing that says you can't do whatever you want. If you're using a class that's not in the same package, you need to use that import statement. The package java.lang is automatically imported for you, which gives you things like system and the main one is system. There's other stuff in there, but system is the more important one. And then the package keyword comes into play in that anything that's declared with package visibility can be seen from within any class inside the same package. Any class inside any other package, however, can't see that variable or method. So we can also have methods and, in fact, variables as well that are not associated with any instance of a particular class, but associated with the class itself. Things that don't really make sense in terms of a specific instance, things that are more general to the concept of what a class represents. Of course, now I can't think of any real-world objects where that's the case. These use the static keyword. Static means it's associated with the class, not with an instance of the class or an object.
So this is a very specific type of class variable.
Is that the final?
It can be.
The reason why I said that is because you use all caps.
I also spelled it wrong. All sorts of wrong. Yeah. So, in order to make this a name constant, I should have a final in here. Meaning that its value can never be changed. The convention for that is all caps, words separated by underscores. However, the only thing that's necessary to make it a class variable is that static keyword. So if I wanted to, for instance, be able to change the default top, I would just take out that final keyword. So other pieces of the program could change to the default top for the throttle, and then in theory I would use this default top in a no arguments constructor that set the size of the throttle to the default top.
Can you still use the old caps in the variable as an alpha?
You can, but it's not convention to.
But it's double with a letter.
Double with allowed. Everything with capitalization is convention. Except when it comes to keywords and primitive types and stuff like that. But that's for a different reason. And the other thing is static methods. Methods that are associated with the class, not with a particular instance of the object. These usually go at the bottom of the class file, or at the top, never in the middle. The middle, everything that's grouped, everything that is non-static should be grouped together. Everything that is static should be grouped together. One should come first. And variables always come at the top of the class file, and then methods at the bottom. So we'll make a very contrived method just to demonstrate. All this does is return a new throttle using default top as the top value. In order to use that, instead of saying instance of throttle dot create default throttle, let's say throttle dot create default throttle and do something like that. Questions? Objects could also serve as parameters to a method. We actually used that when I was trying to make things break, and said control dot toString, pass that into println. And in fact, in this case, I am passing an object to println. I can define methods that specifically take an object as
a parameter, and the definition of that is pretty much the same as taking a primitive type as a parameter. Type, and then give it a name, give it an identifier. Exactly the same as if you were writing a method that took an object as a string as a parameter. You can also return an object value. And in fact, I'm doing that right here. I'm declaring this method as having throttle as its return type, and I'm returning a throttle. On page 86, the book raises a good question. And that question is, what happens when a parameter is changed within a method?
There is one correct answer for this, but it consists of two parts. Does anyone want to venture a guess at either of the two parts? It does have something to do with the distinction between primitive types and class types. And some aspects of that we talked about before. So, when you pass a primitive type into a method, Java makes a copy of that value, and it's now in a method. It's kind of like your method, think of your method as a box with holes on each side. One is for input, one is for output. And variables are buckets. These buckets have very interesting properties in that when you dump the contents of one bucket into another bucket, it actually makes a copy of the contents. So inside your method, you have a bucket on one side that takes the input and a bucket on the other side that will eventually contain the output. When you call the method, you have your inputs in one bucket, you dump the contents of that bucket through the hole in one side of the box into the bucket on the other side that's inside the box. And being that these are really weird buckets and they make copies, it makes a copy of your data. So inside the method, if you change the contents of that bucket, you change the value of that data, it's local to that method, it doesn't change. However, if you are passing in an object, that bucket doesn't actually contain the object, it just contains a reference to that object. So when you dump that bucket into the box, it's making a copy of the reference. So the bucket on the inside of the box has a copy of this value, which is whatever we were
using before, 29CB2795.
But it still points to the same object that you had outside the method, somewhere in memory. So when you make changes to that object, it makes changes to that object both inside the method, from where you can see inside the method, and outside the method. So if you modify that object inside the method, return from the method, that object is still modified. Does that make sense?
Awesome. And perfect timing. It's been an hour and 15 minutes. It's break time. We'll reconvene in 10 minutes. What we'll do for the second half of the class is I'll let you have time to work on the homework that's officially assigned today and is due a week from today. We've learned everything we need to know to do that homework assignment, the main thing being classes and objects. So that this gives you an opportunity to ask me questions in case
not everybody is up to the same base amount of knowledge, because next week we start talking about data structures and we need a foundation to build that on top of. And if you want more practice with this material before you jump into the assignment, I recommend Programming Project 1 on page 95. I don't care if you do it, I don't care if you don't do it, I don't care if you started and don't finish it. It's not graded. The only things that are graded in this class are the 2 exams and the programming assignments. So periodically I will recommend programming projects from the ends of the chapters, but that's just for your practice if you feel you need it. In this case, programming project number 1 looked so cool I couldn't not recommend it. So 10 minutes, we'll reconvene.